Hello guys, welcome back to my channel. In today's video, we will talk about decision tree. We will solve two examples of decision tree and then we will talk about the decision tree induction algorithm and examples. Okay, so let's get started. In this video, there is one example. There will be more videos and series. So I will link them in the description box below. So, yeah, let's get started. Okay, so this is our first question. It is a bit blurry, so please forgive me for that. But yes, so here in this data set, we have given the data of a customer with RID, age, income, if it is if he is a student or not, credit rating, and then if he is going to buy a computer or not. So there are two classes, C1 and C2. C1 means yes, he will buy a computer, and C2 means no, that means he is not going to buy a computer. So we have to create a decision tree that led that is going to lead us towards our decision that whether a person is going to buy a computer or not, and what are the attributes that are going to be that is going to be a dependent attribute and a node attribute and etc. So let's get started. So this is our question, this is the data set. So what we will first do, in forming a decision tree, there are two methods. Okay, one is information gain and second is a Gini index. Two popular methods. Okay. So information gain, there is ID3 algorithm that we are going to use. So I'm going to take two examples. This example we will solve it by information gain, and there will be another example which we will solve by Gini index. Okay, then we will compare both Gini index and information gain, and we will understand more deep into the decision tree in further videos. So in this example, we are going to discuss decision tree with ID3 approach, that is information gain. So what we will do first, we will count the number of classes, that is here it is two classes, C1 and C2, that is yes or no. So we will count number of yes and we will count number of no's, and first we will find out information gain before splitting. Okay, so let's here, as we can see, total number of no's are 5 and yes is 9. Okay, so what is the formula of decision tree is, uh, formula for for creating a decision tree using ID3 algorithm. So information gain formula is, if we are finding information gain for a particular attribute, so then it is minus of pi log pi, minus of pi into log of pi. Okay, and the base is 2, log base 2. Okay, so since uh, we will find out probability, the total number of rows are 14, so 5 by 14, that is pi log pi, that is 5 by 14. And similarly, we will minus it by this, that will be minus 9 by 14 log 9 by 14. Okay, so our decision tree, our ID information gain, what we will get as 0.93. Okay, so for each attribute we will find the gain. Okay, so for student, there is for student there is either no or yes. This for this attribute there are two possible outcomes. There is no, either either the person is a student or it is not a student. Okay, so total number of no's are 7, total number of yes are 7, and the classes for no's, there is 3 yes and 4 no's, and for yes the classes C1 is 6 and C2 is 1. Then we will find their respective information gain. Then we will find their respective information gain, that is 3 by 7 probability of yes, and log 3 by 7 plus 4 by 7 log 4 by 7. Okay, it is minus there, but after solving it, minus minus will cut and it will be plus. So yeah, I directly did it, and the answer is 0.98. Okay, for yes the n is 7, and C1 and C2 we have calculated, it is 6 and 1, and we will find information gain for yes, which will be 0.59, and then we will find total information gain for the subtree, which will be 7 by 14, because it is total number of rows we have is 7, and total number of rows is 14, and total number of no's are 7. So 7 by 14 multiplied by information gain of no plus 7 by 14 multiplied by information gain of yes. So we will get 0.96. Okay. Similarly, we will calculate for credit rating. Credit rating is either fair or excellent. For fair, there is total number of 8, and for excellent, there is 6. Okay. So for C1 and C2 for fair are 6 and 2, and for excellent there is 3 and 3. We will find information gain for fair, that will be 6 by 8, 6 by 8 log 6 by 8 plus 2 by 8 log 2 by 8. It will be minus, guys, but after solving, minus minus will become plus, so answer will be in positive. So 0.81 will be answer for fair, and 1 will be answer for excellent. After finding the total information gain for this subtree, it will be 8 by 14, because there are total 8 fair out of 14. So 8 by 14 multiplied by information gain for fair plus 6 by 14 multiplied by information gain for excellent, and after solving it we will get 0.88. Similarly, we will find out for age. Age, there is youth, middle age, and senior. For youth, n is 5, and for middle age, n is equal to 4, and for senior, n is equal to 5. And then we will calculate their respective classes, sorry, C1 and C2, that is yes and no, 2, 3, and yes no for middle age, and yes no, that is C1 C2 for senior, and finding their respective information gain for youth, information gain for middle age, gain for senior, and then finding total information gain for the subtree, that is 5 by 14, because 5 youth out of 14. So 5 by 14 multiplied by information gain for youth plus 4 by 14 multiplied by information gain for middle age plus 5 by 14 multiplied by information gain for senior, and total will be 0.68. Similarly, we will find for income, and after that we will get student. These are the attributes. These are information gain before splitting, which is 0.93, 0.930 total, obviously, which we have calculated earlier for yes or no. And then for student, after splitting we got 0.96. After splitting, for credit rating we got 0.88. For age we got 0.44, and for income we got 0.89. And then gain, what is the gain? Gain is uh, gain before splitting minus information gain after splitting. So after subtracting them, we get 0.24, 0.05, 0.25, and 0.04. So what is the thing is, we have to take the largest information gain as a node. Okay. So largest information gain here is of age. Okay, so age will be our node. For age, there are obviously three more uh, attributes. There are three values for age, either youth, middle age, or senior. So as we can see in age, if we go again to age, so for middle age, we can see there is no C2. There is no, for no, that is C2 class, there is 0 rows. It means for middle age, there is only C1 class is there. Okay. So we can easily calculate for middle age. If the age is middle age, then the class will be C1. Okay. So we have completed the middle of this tree, uh, subtree. We have done the middle one. Then we will find more about youth and senior separately. So for youth, we will make a separate table for youth, and this will be separate table for income, students, CR, and classes. We will only take those rows with youth in it. And as we have calculated earlier, the information gain for youth was 0.96. Okay. Then we will calculate for in this youth table information gain for each attribute separately. That is, we will calculate for student, which will we get information gain we will get here will be 0. So total information gain, what will be that? before splitting minus after splitting, which will be 0.96 minus 0, which is 0.96 obviously. For income, it will information gain for each, for income is for this one is 0. For this one we have to calculate, we will get 0.5, 0.5, and for L it will information gain will be 0. So now after calculating here, the information gain will be 1, and finding out the total information gain will be, this will be 0, this will be 0, this will be 2. So 1 by 2 multiplied by 1 is equal to 0.5. To information gain for income will be 0.5. So what will be main gain? Information gain will be 0.96 minus 0.5, which will be 0.46. So this will be our gain for income. Total gain for student will be 0.96, for income will be 0.46. Similarly, for this credit rating, it will be 0.02. Okay, so total information gain for credit rating will be 0.02. As we can see here, the largest information gain will be of student, and if he is student, then as we can see here, if he is not a student, then then the class will be C2. As for C1, there is no value. I mean, there is no row for C1. So for this student, if it is not a student, then obviously the class will be 3 only. And if he is a student, then class will be C1, as C2 is equal to 0. Okay, so if it is not a student, then it will be C2. And if it is a student, then it will be C1. Okay, then. Now we will do it for youth. We again find out if it is a student. No. C2. Yes. C1. Now we will find out for senior. For senior, to find out for senior, we will make again senior table, then calculate information gain for each one of that. And after calculating information gain, we will find out that credit rating has highest information gain. So this will be our next node for senior. So this will be credit rate. But if we see in credit rate for fair and excellent, for fair and excellent, as we can see, if a credit rate is fair, then there is only C1. If it is excellent, then there is only C2. There is no C1. So if it is fair, then class will be C1, and if it is excellent, then class will be C2. In this way, we have completed our decision tree for information gain. Now we will jump on to the next question, and we will solve it by Gini index. Okay, so before I have not covered in this, I have directly jump onto the examples of Gini index, decision tree examples, and solving them by ID3 and Gini index. But before that, I would like to tell you what is Gini index. Gini index is basically area between the area under the curve for line y is equal to x, and Lorentz curve, the area between that y is equal to x line and that Lorentz curve is basically a Gini index. So using Gini index, we find impurity, and how using Gini index we will find out decisions and depending attributes, and then create a decision tree. Let's talk about more in this further. So this is our next question, and it is home application class. So we have given home, merit, gender, employed, credit rating, and risk class. Now we have to make a decision tree using Gini index. In this question, we will solve it by Gini index. First, we have solved it by ID3 approach, that is information gain. Here we will use Gini index approach. Okay, so solving it by Gini index. So Gini index formula is 1 minus summation of uh, pi square. So Gini index is 1 minus summation of pi square. There are three risk class A, B, C, and A is equal to 3, B is equal to 3, C is equal to 4. So we will find out Gini index 1 minus 3 by 10 squared, 3 by 10 squared, 4 by 10 squared, and this we will get 0.66. And for each attribute again we will find out Gini index. For Gini index for yes will be 0.64. Gini index for no we will get 0.64. Using similar formula, 1 minus 2 by 5, because for class B it is 2 and total 5, out 2 out of 5, so 2 by 5 squared minus 2 by 5 squared minus 1 by 5 squared. So we will get 0.64. Similarly, for no, we will get 0.64. Finding a total Gini index will be 5 by 10 multiplied by 0.64 plus 5 by 10 multiplied by 0.64. Yes, so the answer will be obviously 0.64. Okay. Now, for married, we will, for each attribute we are going to calculate the Gini index. For married, if it is yes, there are 5 yeses and there are 5 nos, and we will calculate each number of risk class for each attribute. So for yes, a is equal to 0, b is equal to 1, c is equal to 4. Then we will find out Gini index. For yes, then it will be 0.32. For no, it will be 0.64. Total 5 by 10 multiplied by 0.32 plus 5 by 10 multiplied by 0.64, which will be 0.48. Similarly, for gender, it will be 0.34. Total Gini index will be 0.34. For male, it will be 0. For female, it will be 0.48. Then total in Gini index will be 0.34. For then we will calculate for another attribute, that is employed. If he is employed or not, then I'm directly jumping on to the conclusion then, because we have already discussed the process. So for employed attribute, the info Gini index for yes we will calculate. Then for no we will calculate Gini index, which will be 0. Then after calculating total, 8 by 10 multiplied by 0.59, and obviously we are not some writing here, but it will be plus 0. So obviously we are not writing explicitly plus 0. So total in Gini index for this attribute will be 0.47. Similarly, we will find out for credit rating. Okay, so but this one is before splitting Gini index, and this one is after splitting. So as we have seen in information game, we take the node of that which attribute which has highest information gain. Okay, for in Gini index, it is exact opposite. We will take the attribute with smallest Gini index. So here, smallest Gini index is of gender. So gender is either male or female. But as we can see in this gender attribute, we see that for A risk class it is 0, and for C risk class it is 0. But for B it is 3. That means for male the risk class will always be B. Okay, so now with the decision tree, it is already, we have find out that gender is the main node. Then for gender, there are two attributes, male or female. And if it is a male, then risk class will be B. Now we will find out for female. So we will make another table for female, gender female, married, employed, credit rating, home, or and risk class. Here, Gini index for female we have already find out, which was 0.34. Before we have already found out, right? So now we will calculate for each attribute again. For home, looking into table, obviously we will count the for home we will count the number of risk class. For no's we will count the number of risk class. For yes, so yes, after this, we will calculate Gini index individually. Gini index for yes, it will be 0.44. For no, it will be 0.5. Then total Gini index will be 3 by 7, because there are 7 number of females there. So 3 by 7 multiplied by 0.44 plus 4 by 7 multiplied by 0.5. The Gini index will be 0.47. Similarly, for married attribute, total Gini index will be 0. As we can see here, we can already see that since it is 0, which obviously probably the most minimum Gini index, so I guess the next attribute will be married only. So even we can see here that for yes there is only C, there is only risk class C. That is, if person is a married, then risk class will be C. If person is not married, then risk class will be A. Okay, note that down. And obviously we will complete all the process. So for credit rating again, we will calculate the Gini index, and for credit rating we will get Gini index to be 0.47. Among all the attributes, the Gini index for merit will be lowest, obviously. So, gender, male, female. If it is a male, risk class will be B. And if it is a female, we will check if it is if the female is married or not. If the female is married, then risk class will be C. If female is not married, then risk class will be A. In this way, we will calculate decision tree. In that way, these are the two approaches for decision tree, for making decision tree. And these two algorithms are most popular algorithm for decision tree construction. Now we will compare these two process, that information gain and Gini index, how these are different and which one is beneficial, which one is more beneficial. So obviously we'll talk about attribute comparison based on information gain and Gini index. So, in terms of fairness, information gain is not necessarily always fair, but Gini index is a balanced treatment of attributes. Okay. For preference of attributes, information gain always favors the attributes with larger number of values. Remember it. It always favors the attributes with large number of values. But for Gini index, it is not biased towards multi-valued attributes, many value attributes. It means attributes with so many values. It has no any not any particular biasness towards the number of attributes. But information gain has. Issues with multi-valued attributes, we have already discussed potential selection of suboptimal attributes. Okay, but there is nothing of such sort in Gini index. Now, for risk of overly wide trees, so obviously for information gain, there will be risk of overly wide trees with depth one, but there is less likely to be the result of overly wide trees in case of Gini index. And for impurity consideration, there is not impurity consideration in information gain. It is basically the principle for Gini index. So there will be explicit consideration of impurity in the data for Gini index. So that's all for today, guys. Stay tuned for next video. But if you have any confusion regarding this video, I hope I will recommend you to check out the video about mathematical expression for information and Gini index, and link will be in description box below. So if you are not able to understand these things, I think you haven't seen that video, so I will recommend you to see that video first, and link will be in description box below. So thank you guys for watching.